Since I'm stating it's perfectly elastic, I know kinetic energy is also conserved. So I'll have two equations. So afterwards, my 3 kilogram mass will have some V3 final. My 2 kilogram mass will have some velocity of 2 V2 final. I don't know the direction, I just know that they will be moving most likely. I have two unknowns. I need two equations. One equation is conservation of momentum, the second equation, conservation of kinetic energy. So I can avoid writing bad subscripts. I'm just going to call this one A, and I'm going to call that one, actually, for purposes later on, I'm going to call that C, and I'm going to call that D. So I start out with my initial momentum. I have 3 times 4 plus 2 times -5 is equal to 3C plus 2D. That is my conservation of momentum equation. It just did mass times velocity individually plus added and then individually afterwards. I don't know what C and D are, that's what I'm trying to find. My second equation, I know kinetic energy is conserved. So that's 1/2 times 3 times 4 squared plus 1/2 times 2 times 5 squared equals 1/2 times 3 times C squared plus 1/2 times 2 times D squared. I have two equations, two unknowns. We've already done some of the math here. So we have 2 equals 3C plus 2D, and 49 equals 1.5 C squared plus 1 D squared. If I recall correctly. How do you solve it?
Is there a way to
What'd you
set
do?
equal to each other?
Well, I have if you want to solve,
I mean, like separate like each of the unknowns into their own side and combine the like terms.
you could. You want to go that route?
Sure.
So what do you want to solve for?
See.
All right, so in this one right here, we have 2 minus 2D divided by 3 equals C. And down here, we have 49 minus D squared over 1.5 is equal to C squared. So C equals plus or minus the square root of whatever that is.
7 minus D.
No. Not the way square roots work. I don't know if the positive or the negative is the right solution. If C is negative, then that means it's going to the left. If C is positive, then it means it's going to the right. Now what? No, set them equal to each other? So I have 49 square root plus or minus the square root of 49 minus D squared over 1.5 equals 2 minus 2D over 3. One equation, one unknown. You want to solve the positive one or the negative one first?
Positive.
Or actually, we're probably just going to square both sides. So it doesn't really matter if we do positive or negative there. So I have 49 minus D squared over 1.5 equals that squared 4/9 times 1 minus 2D plus D squared. Make sure I didn't make a careless error there. squared, 4/9, and then 1/2. Okay. Now what?
So this, where we put in a quadratic formula.
All right, put in quadratic form, we need to, well, first, so I have 49 over 1.5 minus d squared over 1.5 equals 4/9 minus 8d over 9 plus 4/9 d squared. I'm just gonna multiply everything by 9 to get rid of my fractions. That's just an option, so I get 6 times 49, which is 4, 5, 294. So I get 294 minus 6d squared equals 4 minus 8d plus 4d squared. Now what?
You combine the terms.
Okay.
X equal to 0.
So 0 equals, I get 10d squared minus 8d minus 290. Now what?
Quadratic formula.
All right, I am going to just divide by 2 to make the number slightly smaller. 0 equals 5d squared minus 4d minus 145. All right, so quadratic formula. So d equals 4 plus or minus the square root of 4 squared minus 4 times 5 times negative 145 divided by 2 times 5. I'm gonna have 2 answers, and then we have to figure out which one's the correct one. And from here, I know this gave us, I erased it unfortunately. I'm hoping someone's figuring that one out. This was C is equal to 2 minus.
$5.8.
-5.
So if D is 5.8, C is 2 minus 2D. So C would be 2 minus 2 times 5.8 over 3. And here C equals 2 minus 2 times negative 5 over 3. So what's the first one?
Negative 2.87.
876?
867, I guess.
7 meters per second. All right, I will tell you that we have done something correctly here. There are 2 answers, one of which I was expecting. Which of those solutions is correct? The 5.8, negative 2.867, or the negative 5 and 4? In both cases, kinetic energy is conserved and momentum is conserved, but only one of those is the correct answer.
guessing the bottom.
The bottom.
So you're saying the bottom one's right, or you're saying the top one's right? Alright,
It's
so why is the bottom one right?
It's for C, and C is going to the right, and if we're establishing right is positive,
Yeah.
then if it was the top one, that means it would be going to the left.
And what's wrong with that?
Because C is going to the right, which means it has to be going positive.
It says C's going to the right.
The arrow.
Oh, the fact that I drew that? But if D is a negative number, that means that it's the opposite direction.
They have to have the same signs. C and D.
C and D don't have the same signs in either case. It's, that's the solution, or that's the solution. Giovanni, why are you saying the top one's right?
Yeah.
Why? Gut?
That and mostly because it's more of a specific answer, not just a single digit.
Think about the original problem, the before answer. What was the initial velocity of the 3 kilogram mass?
Initial velocity.
Yeah.
4 meters a second.
And for the 2 kilogram mass?
5 meters a
Oh,
second.
yeah, the top.
-5. When we went through all this, we came up with 2 solutions. So we have these 2 objects heading towards each other. Before they touch each other, there's no acceleration whatsoever. There are no other forces acting on them. They're heading towards each other. And we get, so it has a certain amount of momentum, certain amount of kinetic energy. It still has the same momentum, same kinetic energy. It still has the same momentum, same kinetic energy. They collide. This solution here assumes that they don't actually collide. Either they pass through each other, or they haven't gotten to the collision point yet. This is the correct answer. So when you're going through this method here, where you set up the 2 equations, you have the linear equation and the quadratic equation, when you set that up, one of your solutions should be the original problem. If you do not get that in the original problem, then something's gone wrong. That's why I said I know we've done something right, because one of our solutions was the original problem.
So the one that's not the original problem is the answer.
Yes. Now, there are other techniques that I'm going to introduce. The nice thing about this method is the fact that we get an immediate check of some validation. The other techniques have the advantage of you're not dealing with quadratics. But that will remain until Monday.
Test.
Oh, that's right, stuff to hand back. If you don't want it now, I can give it to you later, also.